Now before we start, here's a little disclaimer. Don't replicate actions you see in this video with malicious intent. Don't hack other people, it's illegal and dumb, okay? Thank you. What's up everyone? Today I'm gonna show you how to create a keylogger that sits inside another program. In our case, we're gonna take Spotify and inject our malware in it, so that the user is completely unaware that we are even spying on him. Now, before that, I need to introduce you to some basic concepts so that you can fully understand the code. But don't skip, stay with me, it's gonna be very easy. Let's start with processes. So a process is an instance of an app, which basically means that you can imagine it as a container that holds everything your app needs to work, like code, memory, data, and everything else. An app can have multiple processes, like Audacity. Okay, this one actually doesn't have multiple processes, but Spotify does. So you can see 6 more. These processes beneath the main one are called child processes. As you can see, there can be 3 types of processes in Windows. These are apps. Those are applications that were launched by you, like Chrome, Spotify, Audacity, things like this. Background processes. These one doesn't. They don't need to be launched manually by you. Sorry. They mostly are launched by themselves, as they are set up this way. And third category, Windows processes. These one are very important because they make your Windows operating system work. So they handle things like memory management, security, drivers. For example, your graphic card drivers is most likely a Windows process. These are launched automatically on system startup. Each process has a priority setup, which is basically an equivalent of CPU time that it gets. If you set a real time, which is the highest priority, to a resource-hungry process like a video game, for example, it will probably make everything else run really slow or even break, like your mouse or keyboard. Oh, and there's one more thing. These processes, they believe they are completely alone. They don't see each other, and they believe that they have all memory just for themselves. It's called virtual memory, and what it does is give the process a virtual address space for it to use, and then MMU, Memory Management Unit, handles mapping virtual addresses to physical addresses. It provides many functions, including multitasking, allowing multiple processes to access the same shared library in memory, swapping, and many other. I'm extremely simplifying here, but if you wanna know more, check out Gary Explains video, link in the description. But all of these processes are extremely heavy, and the more of them you're running, the slower your PC is. The answer to this problem are threads, which are extremely light, and the process can have multiple of them, which is called multi-threading. So if you have a football team, each player is a single thread, and it does its part of a job. They work together to achieve the overall goal. And I'm sure all of you just wanna start writing code already, but I promise you there's one last thing to cover. What are DLLs? Dynamic Link Library is a shared library concept developed by Microsoft. These are basically sets of functions that can be reused by different processes even at the same time. It not only saves resources, but also time of programmers. They don't have to recode the same thing each time they make a new program. That's how very basic DLL code looks like. Let's start from the top. We are including Windows.h library, which basically allows us to use all Win32 API functions. Then we create a function sayHello that pops a message box, and it's exportable. We don't actually need that, but this one part of the line means that if you include this DLL in your other code, you would be able to call sayHello in the other code. The entry point of our DLL is DLL main function, which has 3 parameters and this weird looking switch case. It's not weird, trust me. It's also well documented in the documentation. So as for the syntax, hinst DLL, which is a handle to the DLL module, the value is the base address of DLL, and the H instance of a DLL is the same as the H module of the DLL, so hinst DLL can be used to call to functions that require a module handle. FDW reason is the reason code that indicates why the DLL entry point function is being called. This parameter can be one of the following values: process attach, detach, thread attach, and thread detach. We have all of those values here. We actually don't need those three because we are not gonna use them. But as you can see, as soon as the DLL process attaches, we will call say hello, and it will pop a message box. So actually, let's try it. Before you compile, make sure to set the properties of your Visual Code project from application.exe to dynamic library.dll, apply and OK, and hit build compile. Wait, sorry, no, actually hit the this like green triangle here. Okay, now let's go to the keylogger itself. We're gonna start with a DLL main function. As you can see, it's the same as before. We have 3 parameters, a switch case, and we are using this time DLL process detach and process attach. It's important to know that we are initializing a handle to a hook, handle to a module or an instance. It's if you control and left click here, you will be brought to this absurdly big file, and you can see that H instance can be used in place of H modules can be used in place of an instance. It's basically a handle to a module and a file. So we are opening a file in this directory with append parameter, because we can open a file and read from it. We can write and we can append to a file, and then we are creating a thread with create thread function that has 6 parameters. And now let's read what do they even mean. Okay, so the first parameter of create thread function is LP thread attributes, and it is basically a pointer to a security attribute structure that determines whether the return handle can be inherited by a child process. We set it to null because we don't really care about inheritance right now. DW stack size as the initial size of the stack in bytes. The system rounds the value to the nearest page. If the parameter is 0, the new thread uses the default size of the executable. We are setting it to the default. Third parameter, LP start address, the pointer to the application defined function to be executed by the thread. We are gonna be executing my thread function right here. Next, LP parameter, a pointer to a variable to be passed to a thread. We are passing no variables, so null. LP, DW creation flag, the flag that controls the creation of the thread. So it's either, yes, we are setting it to 0. So the thread runs immediately after creation. And the last parameter, LP thread ID, the pointer to the variable that receives the thread identifier. So we can actually, for the debugging purposes, set a pointer to a variable here, so we can later use these, either print or use somewhere the thread ID, but we won't use it anywhere, so there's no point of defining it. Now let's move to myThread function. So myThread function sets a handle, a hook handle, right, to set Windows hook EX with 4 parameters. And now if we check the this function in the documentation, let me see it. It's gonna be this one. Yes. Okay, so as you can see, it has 4 parameters. First is ID hook, the type of hook procedure to be installed. This parameter can be one of the following values. We want to monitor keystrokes, so we are setting our parameter to wh keyboard ll, which installs a hook procedure that monitors low-level keyboard input events. For more information, blah blah blah. So that's our ID hook. The second parameter is keyboard procedure, which is another custom function. And according to the documentation, it is a pointer to a hook procedure. If the parameter is okay, that's some other parameter, but yeah, this is basically a pointer to a hook procedure, and the procedure is here. I will discuss it in a minute. Third parameter, H instance, a handle to a DLL containing the hook procedure pointed to by the LPFN parameter. This is a handle to a module declared here earlier. So to our DLL, right? And the last parameter that is set to 0 is the thread ID, the identifier of the thread ID which the hook procedure is to be associated. If this parameter is 0, the hook procedure is associated with all existing threads running in the same desktop as calling thread. We are setting this to 0. Now let me break down keyboard procedure function for you. As you can see, with the magic of editing, I've added some additional comments, so it's easier for you to understand. Now, keyboard procedure. It's a function. It's a function documented in Microsoft's documentation. It takes three parameters: code, wparam, and lparam, which are a code the hook procedure uses to determine how to process the message. With haction 0, the wparam and lparam parameters contain information about keystroke message. That's what we are doing here. Then we are getting the structure containing information about a low-level keyboard input event. Then we need to check if a key is being pressed down. Okay, I'm going too fast. Let me tell you about this wparam and lparam first, maybe. So it's a virtual key code, wparam, a virtual key code of the key that generated a keystroke message, and lparam is the repeat count, scan code, extended key flag, context code, previous key state flag, and transition state flag. For more information, so it could be many things, right? But this is the what's the most important for us, I think. I can say that because it holds the actual key code, right? So let's go back to the code. We are here. We are checking if our file is not null, the file test.txt that holds keystrokes. We are checking if pressed key is the enter key, and if so, we are printing a new line to the file. Then we are getting a state of a shift key and initializing variable to hold the character, and also an array to hold the state of each key on the keyboard. We need shift state to later check if the character is lowercase or uppercase. But first we need to get a current state of the keyboard and use toASCII function to translate the virtual key codes and keyboard state to the corresponding character value. Check if it's lowercase or uppercase, and write the correct character to the file. Now we are using fflash function to write characters immediately rather than make computer store it in a buffer. It's not efficient, but we make sure that every key will be saved. And now the only thing that's left is a script that injects a DLL into a target process. Let's take a look. We start the injector code by including two libraries, windows.h and standard input-output.h. This is pretty much only for debugging purposes. We also use it to pass parameters, but you could hardcode it, so it's not necessary. But yeah, first it's an executable file, and we will.exe, and we will pass it a process ID and DLL path, our keylogger path. We are converting process ID from string to a number and saving it in process ID variable, and we are saving DLL path in DLL path variable. First thing, we need to open a target process. So we are using open process function. Let's see the parameters in the documentation. It takes desired access, which I will tell you in a bit. Inherit handle. If the value is set to true, process created by this process will inherit the handle. We don't need that, we set it to false. And the last parameter is process ID. So this desired access, we can choose it from these values, and it gives us basically, we can give our script an access, a specific access to a process. So what can we do with it? I'm giving myself all access so that nothing can break, or maybe more things can break, but I can do more stuff. Next function is virtual alloc ex. It takes a handle to a process and a bunch of other arguments. Let me check it in the documentation. Handle, LP address, DW size, allocation type, and protect. So a handle to a process, that's obvious. LP address, the pointer to a specific that specifies a desired string address for the region of page that you want to allocate. We are passing null here. Yes, we are passing null here, so the function determines where to allocate the region by itself. It's doing the whole job for us. Third parameter is the size of a stack. We set it to size of our DLL path +1. The fourth argument is allocation type, and we are setting it to memory commit and memory reserve. Now, memory commit allocates memory charges for the specified reserved memory pages, and memory reserve reserves a range of the process's virtual address space without allocating any actual physical storage in memory. So we first allocate the space, so we are saying, hey, I want this space, and then we are committing the actual physical data to reserved space. And the last argument is protect, so the memory protection for the region of pages to be allocated. We want to have a read-write, but there is many of others that you can choose from, as you can see. But page read-write is completely enough for us. By the way, all of those if statements, these are just for debugging purposes, so if any one of these breaks, we know at what point. But these aren't obligatory. You don't have to write those. Next function: write a DLL path to the allocated memory in the target process. It takes a couple parameters too. Our handle to a process, base address, which is our remote buffer, LP buffer, which is DLL path, size, which is the length of DLL path, this length of the string +1, and number of bytes written. This parameter is ignored if we pass null, because we don't need to receive this the number of bytes. So we pass null here. Next thing, we have to load kernel32.dll library, so we can then use load library A. Yes, and we get the address of this library with get procedure address. It takes only 2 arguments, a handle and the library name. And again, if statement if it breaks. Create a remote thread in the target process to execute library A, load library A with the DLL path as argument. We are using a create remote thread function for that, and this one is actually surprise also documented. Everything from here is documented in this documentation. So actually, really, I advise you to get used to browsing through it, get used to the layout. It's super helpful. So it takes a handle to a process, this one. It takes thread attributes. We pass null here, so the thread gets a default security descriptor, and the handle cannot be inherited. Excuse me. Start address, which is stack size, which is 0. Why? Because if this parameter is 0, the new thread uses the default size of the executable. So we are setting it to default basically. Fourth, start address, a pointer to the application defined function of type lpthread start routine to be executed by the thread and represents the starting address of the thread in remote process. We specify that, and then remote buffer, which is basically a pointer to a variable to be passed to the thread function. Yes, and the last, no, not the last. Now the creation flag, we set it to 0 because we want our thread to run immediately after creation. We can pass here create suspend. Stack size param is a reservation, so 2 more values can be passed, but we don't need to know about them right now. And LP thread ID, again, we won't use thread ID anywhere, so there is no point of getting it, so null here. And the last function is wait for single object. It only takes 2 parameters. It's also included in documentation, but it basically means that our thread will be running, and it will be running until we close the I'm sorry, my voice is not working really well after all these hours recording. It will end, the thread will finish when we close the window, for example, Spotify window. So, for example, let's say that we are injecting our DLL. Let's stick with the Spotify example. We are injecting into Spotify and wait for single object, waits until our thread finishes. And as you can remember from the Keylogger code, it runs infinitely. So to finish it, we need to close the process that it is attached to. And then we will finish the script. Here is some cleanup, and printf DLL injected successfully. So finally, let's try this in action. You can compile it by pressing build and compile. As you can see, one succeeded. Open up PowerShell, cd x64 debug, and here it is, our DLL injector. Let's run Spotify and process hacker so we can quickly determine the process ID of Spotify. Now, DL Injector in process hacker. Let me clear this. Spotify is 8460, and the path to let me delete this, and the path to Keylogger.dll is here. Copy as path. Ctrl V. So now if you hit enter, you can see that DLL injected successfully, and okay, then let's generate some keystrokes first. So, for example, hello world. Hit enter. Of course, it will throw an error here, but then we can do something like this. Yeah, I don't know, bye. Right? And if you close Spotify, or maybe, okay, let's not close it yet. I'm gonna show you one more thing, because if you hit properties, if you click properties, and look at files, look at handles to files, there should be something very unusual. Let's look at closely, and here it is. Here is a handle to a test.txt file. You remember, this is the place where our keylogger stores all the keystrokes. So we can finish Spotify. As you can see, the process is no longer available. And if you go to this directory, there is a file that contains hello world. This is the result of not implementing backspace character, for example. But you can see if you hit enter, it goes to the next line. So that's how you inject a Keylogger DLL to another process. That's it for today. Thanks for watching, and remember that Keylogger is a malware. Don't run it against other people without their explicit permission. You will get in trouble for doing so. And if you are interested in more dark web and malware related topics, check out my Twitter. I post very often there. Link in the description. See you soon.